1/2, blah, 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 and all that stuff. It doesn't, so we want it to equal 0, but because it's equal to 0, it makes it uglier. But, if you go back to factoring days, oh no, I don't want to hear that. No. You can do the guess and check stuff, which I'm guessing is at this point what most people probably did that actually tried this problem. The way that we did it in here, if you want to go back, 4 times minus 6 is minus 24. Factors of 24 that subtract to be 5 are?
8.
Huh?
8 and negative
8 and 3, which means that the outside is either 8 cosine theta or 3 cosine theta, and the inside is the other one. And remember, how do we get 4? It's either 2 times 2 or 4 times 1. And how do we get 6? 1 times 6 or 2 times 3, right? So we need some combination of one of those and one of those to get 8. And if we do that, that should set up the whole problem. So the only way we can do it is by doing this and this, right? So I'm guessing that the people that actually tried to factor this that had trouble were probably trying to make this 2 and 2 and weren't really thinking 4 and 1. So here we're going to have 4 cosine of theta and 1 cosine of theta. With me there? And then to get the 8, this has to be 2. And if this is a 2, then this has to be a 3. And so our outside becomes 8 cosine of theta, and our inside becomes 3 cosine of theta, which works exactly as we wanted it to. With me? Remember this, at least to some extent?
Yeah.
All right, tell me about signs. Yeah, they're different signs, and it has to be a positive 5, so to get a positive 5, we better put a plus there and a minus there. Okay, factoring is done. Now what? Set them both equal to 0. So 4 cosine of theta minus 3 equals 0, and cosine of theta plus 2 equals 0. So for the first one, can I just write cosine of theta equals 3/4? Okay with that? And that angle is?
41.
Not on the chart, right?
Yeah.
So, we got to use the calculator, and the calculator says what? 41?
41.
They want degrees and 2 decimal places. So, theta is 41.41 degrees. Okay. That is our reference angle, and we need it in, no, degrees, but where?
Oh.
1 and 4, because cosine is positive. So, does that help us? Is that one of our answers?
Yes.
Because that's our first quadrant angle. The reference angle is our first quadrant angle. And then we also need to put it in quadrant 4. So to put it in quadrant 4, we would do 360 minus, which gives us 318.59 degrees. They say between 0 and 360, so that's all for that one. What about this one? Cosine of theta equals -2. Thoughts? Go ahead, throw it into your calculator. Huh? Take it back. What's going on? Why aren't you giving me an angle? Why doesn't it work?
It's negative.
Wait, because it's bigger than, it's outside of -1 and 1.
Cosine of theta equals -2. Well, what do you know about sine and cosine?
They're in between -1 and
They're
1.
never greater than 1 or lower than -1, right? So when will this happen?
Never.
Approximately never. So that's gone. And those are only two answers. Does that make sense?
Yeah.
Huh? What are you yelling at me about now? I was on the Muppets. I understand. I coach softball. Little League.
Are you still coaching alone?
Am I coaching what?
Are you still coaching alone?
Well, no, I have assistant coaches, but I wasn't supposed to have assistant coaches. I was supposed to have a co-coach,
Yeah.
but
Maybe I'll-
he's not a big fan of being a co-coach. So, in effect, yes. Questions here? Any others? Let's move on. Sounds good to me.
David, I like this song.
For the rest of class, our answers should all be in the interval of 0 to 2 pi. Okay? All right. So we're on the far right there. We say sine of theta equals negative cosine of theta. I have X's, yeah. Sorry. What don't you like?
That they're equal to each other.
What was that, David?
The sine and cosine of both sides.
We have a sine and a cosine. We would, I mean, we didn't really like this problem, but at least it was all cosines. And we knew what we had to do. We didn't like doing it, but we knew what we had to do. Here we got one fresh, which could be a little bit of a problem. Because I don't like having two different functions in the same problem. Is there any way that we can avoid having two functions in the same problem?
The identities.
How about this? Does that help?
I thought identities too, but I don't think we can because
I would leave,
What?
I'd leave it as, because watch what happens when we do this.
What about
What's the left side?
identities because they're so equal to each other.
I'm sorry?
that's when
Tangent
you-
of x, and what's the right side?
-1.
And that problem just got a whole heck of a lot easier, didn't it? Now, we can't divide by a trig function to get rid of terms, to get rid of, like if we have two terms that have cosine in them, we can't divide to cancel out a trig function.
So we can't do that.
This is fine. We're not canceling out a trig function, we're just kind of adjusting. So there's a kind of a fine line. I'll show you one that talks about what I mean there. But we can do this, and now all of a sudden this problem's not that bad, right? Tell me about it. What do you know? What's the reference angle? 45 degrees, 5 or 4. Right, we're in radians here? Quadrants, 2 and 4 because tangent's negative, good. So x doesn't really equal pi over 4. I was joking there. Pi over 4, quadrant 2 and 4. Oh, this is that pi over 4 stuff. I remember that. Pi over 4,
3 pi over
3
4.
pi over 4,
5 pi
5
over 4. 7 pi over 4.
So our answers for x are
3 pi over 4.
3 pi over 4.
3 pi over 4,
7 pi over 4.
7 pi over 4. And we'll be done. You okay there? This is black. All right. Here we go. Anybody still need this one? Secant of x plus tangent of x equals 1. Alrighty. Hundreds. Nice chat.
Can't win them all.
Tough cross.
Alright, talk to me. Thoughts?
Turn into sine and cosine.
Sine and cosine, okie dokie.
Don't mind me.
Cosine of x plus sine
Plus
of
sine
x
of x
over
over
cosine
cosine
of
of
x
x
equals 1.
equals 1.
Okay. Now what? Adam.
Sine of x over cosine of x.
Like that? Okay. You're looking at that going, it hasn't helped us as much as I thought, right? Okay, so just keep going and see what you can come up with. Next. Shannon? Multiply by cosine?
Yes.
You don't like the fraction, so get rid of it? Makes sense to me. 1 plus sine of x equals cosine of x. What don't you like? Everything. We still have a sine and a cosine. Yeah, that's the problem. And that's what makes this one hard. Try something. Because otherwise we sit here and go, we don't accomplish anything, right? So try something.
Oh, subtract the 1. And then we can get Pythagorean identity.
Pythagorean identities.
But it's not squared.
It's not squared. Can we square it?
Square it? Yeah.
Are we allowed to square both sides?
Yes.
Why not? I don't know. I mean, I don't know if it's going to work, and that's the problem with some of these. You're going to try stuff, and you don't want to do something unless you know it's going to work. But we got to start getting out of that because we got to try stuff. And if it works, great. If it doesn't work, so be it. We'll try something else. So you want to try squaring this? Square both sides?
Yeah.
Something like that and that. All right. What do we get?
1 plus
1
sine.
plus.
Plus 2 sine of x.
Why?
Sine. Square double square.
Square double square. Yeah, this is a square double square thing. So we can't. So 2 sine of x
Plus sine squared of x
plus sine squared of x
equals cosine.
equals cosine squared of x. Okay. Why? Why what? I see a couple of different ways we can go right now. But I think that the squaring of both sides is going to allow us to get home. I think that was a huge move right there.
Subtract the 1.
Subtract what?
The 1.
Subtract the 1. Okay?
Change it to signs.
So 2 sine of x plus sine squared of x equals cosine squared of x minus 1. Like that?
Yeah.
Okay?
Then change it to sine.
Change what to sine?
Cosine squared of x minus 1.
Is cosine squared of x minus 1 equal to sine squared of x?
No.
Sine squared of x plus cosine squared of x equals 1.
It equals negative sine.
So it'd be 1 minus cosine squared of x. Can we do anything?
You can change it to negative sine squared of x.
No.
Because cosine squared of x minus 1 equals negative sine squared of x.
Cosine, so you can get that from this? Cosine, can we get cosine squared of x minus 1 from this?
Yes.
So if we subtract the 1,
And then subtract the sine
and
squared
then
of
subtract the
x.
sine squared,
You get negative sine squared
Negative
of
sine
x.
squared of
I
x.
gotcha. So you're saying that cosine squared of x minus 1 is negative sine squared of x?
Yeah.
I would agree. That's why you gotta be careful about Pythagorean identities, because you get that cosine squared of x minus 1, you go, yes, I got a sine squared of x. But it's not, so just be careful. All right, now what? Oh, this is what I'm talking about before. We cannot divide by sine of x in order to get rid of sine of x. Because, well, I'll show you in a minute. But instead of dividing, what can we do?
Add or subtract.
We can add or subtract. What would we like to have in this problem?
Positives.
It starts with a z.
Zero.
Zero.
So
We'd like to have
add.
0. If we have 0, what can we do?
Add sine squared of x.
No, but if we get 0, what can we do after that? Vector. So, let's get 0.
2 sine
2 sine of x plus,
2 sine squared of x.
we're adding sine squared of x, so it's sine squared of x plus sine squared of x gives us 2 sine squared of x equals
0.
0. And now, we can factor. Take out the 2 sine of x.
Side of x. 1.
1. Sine of x.
1 plus sine of x. Wanted to put a theta there. Does that make sense? Now, I want to go back here for a second. If we had divided by sine of x, okay, what we would have had was 2 plus sine of x equals sine of x. And basically, what we would have ended up getting is this. Is that a big deal?
Yes.
Why?
Because it
Whole
cancels
chunk of the
out.
problem is missing.
Yeah, because we'll lose answers. If we divide by a trig function to get rid of the trig function, we will lose answers. But whenever you start thinking, let's divide by it to get rid of it, instead think, let me get it to the other side and factor it out. Because that way you'll accomplish the same thing, but you'll retain the answers that you were going to get. Does that make sense? I thought you...
No, yeah. So like, how do you tell if you divide? It's like on that one.
In this one, we wanted to change it to tangent. We weren't trying to get rid of a term. We were just trying to change the function. This is okay. Changing from sine to tangent, that's going to be okay. If we were to divide here, it would be to get rid of all those signs. Does that make any sense at the difference? I understand it's a fine line, but if we divide here, it's to get rid of signs. And we can't do that. If we divide here, it's to just change it to tangent, that's okay. All right? Okay, now what? Okay, so 2
Sine of x
sine of x
equals
equals 0. You can speak louder than that, that's okay.
1 plus sine of x equals 0.
Equals 0. Okay. So,
Equals 0. Equals 0. Equals 0.
okay.
So x.
You're allowed to
equals
make mistakes.
0.
Believe it or not, I have made mistakes too. Hard to imagine, I know. Just kidding.
X equals 0.
X equals 0. The cap is not yet on the pen.
We have another.
Sine, or X equals 0.
180?
Can it? Remember that sine represents the y coordinate. And if we're looking at the unit circle for where the y coordinate is equal to 0, where is the y coordinate equal to 0? There, x-axis. So 0
Pi.
and there, which is
Pi.
pi. We're in radians, so we got to go pi.
And 2 pi.
Okay with that? We done with this part? Yes. It would be 2 pi,
Oh, but not equal.
but there's no equals there, so that's why it's not. But otherwise it would be. 2 pi would make that true also. All right, how about this guy?
Sine of x equals -1.
Sine of x equals -1. So remembering once again that sine is
Y.
y.
So 3 pi over 2. 3 pi over 2.
Where is the y coordinate -1?
2 7.
Down at the bottom, which is
3 pi over 2.
3 pi over 2. Is that the only place that the y coordinate is -1?
Yes.
Oh.
Yes, it is. I have some bad news. I did not hit the power button. No, I'm just kidding. I mean, that is bad news, but that wasn't what I was trying to get
Well, it's not bad for us,
at. No, thank you. That was a,
What do you guys think? Nice.
no, they were taking it as, according to you guys, I shouldn't be allowed to win lots of money. But I took it as a compliment, whether you meant it that way or not.
I did.
We did something, we did everything we did was fine. And everything we did was what we needed to do and legit and legal and all of that. But there is one step that's a problem. And we have to pay attention to that. And that is the red step. Squaring both sides. Remember how we said that whenever we take the square root of both sides of an equation, we have to go plus or minus? Because it's doing something. Like when you take the square root of something, let's try that again. When you take the square root of both sides, you might be losing answers. And so you got to make sure that you go plus or minus when you do that. When you square both sides, you have the potential of gaining answers that are, holy cow, blah, 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 blah. What was the word? Extraneous. Well, we used that word earlier in the year. We said extraneous roots. And so what we had to do when we did that was we had to go plug stuff back in and make sure that everything was cool. And so that's why I said I have some bad news. Because when we square both sides, we got to check our answers. And you know that I haven't done a lot of the checking of the answers as we've been going along, because that would make me critical, because I'm not very good at checking answers. But when we do stuff like this, we do need to. So, let's check our answers. X is 0. Secant of 0, so that's the reciprocal of cosine of 0. What's the cosine of 0?
0.
Oh my god.
90? Wait, oh wait.
I forgot.
Chart test.
Turquoise.
Hold on, chart.
What's the cosine of 0?
1.
Oh, so much better. What's the reciprocal of that?
Wait.
What's the cosine of 0? 1! What's the reciprocal of that?
1.
Yes, the reciprocal of 1 is 1. Plus the tangent of 0.
0
1 plus 0.
equals 1.
We're good.
Yeah.
Cool. Pi. So secant of pi is the reciprocal of the cosine of pi. What's the cosine of pi?
0. Oh, yeah.
Remember that cosine is the
X.
x coordinate. So what's the x coordinate out here at pi?
-1.
X coordinate.
-1.
-1. X coordinate. What's the reciprocal of -1?
-1.
I know that.
-1. Plus, what's the tangent of pi?
Tangent
Well,
0.
remember, it's the same reference angle, right? That's how we got here in the first place. 0 and pi are the same reference angle.
0.
So the tangent of pi is
0.
0.
So it doesn't work.
So we have -1 plus 0.
Equals 1.
Definitely.
Doesn't work.
Oh, that don't work.
Pi doesn't work.
Oh no.
Bye, guys. So, since we found the one that doesn't work,
We gotta check the other one too.
we do? I figured we got the one that doesn't work, so we're got to check them all. All right, 3 pi over 2. 3 pi over 2. Secant of 3 pi, wow. Okay. Cosine. Cosine is the x coordinate. X coordinate at 3 pi over 2 is 0. So the reciprocal to get secant is,
0.
what's the reciprocal of 0?
Oh,
Undefined.
yeah.
So that doesn't work.
Ooh, undefined. That's instantly bad.
Yes.
That guy's out also.
So 0.
So we did all that to figure out that x is 0.
Nice.
Yes.
Oh, that's annoying. But it is. It's just what we do. Now, I think, and I have not tried this, I actually don't know for sure, but I think that had we squared both sides at the very beginning, we might have avoided maybe that one, but I'm not sure. We might not have.
Isn't I,
I'm just not hearing anything you're saying, but, no, please go, please.
if we would have squared it at the beginning, it's kind of like.
Yeah, but we still would have had that middle term like we did here. We still would have had to go square, double square. So we would have had the secant squared of x plus the tangent squared of x, but we would have had plus 2 secant of x tangent of x. You know what I'm saying? And so that's where I think we would have ended up getting our answers from. All day today I did it this way. This is the way that the classes kept saying to go, so we did it. Never tried squaring it from the beginning. And this is probably the way I would have done it too. So, but it's a significant problem. I think we're even doing stuff that's even more advanced than we did in like September and that. You know? I would consider this probably more advanced than what we did in September.
Really?
Maybe.
Really?
Just a little bit. Yeah.
Alrighty, let's see.
I'm in shock. I never would have thought. You've truly astounded me, Mr. Anderson.
Oh, I didn't tell that. You can't do. Take this off your homework and tell people in second hour if you happen to know them or run into them. Do not do 71 or 75. Do not do 71 or 75. They come from, we would need formulas that, from like section 7.4 or 7.5 and that. And since we went 1 to 8, we haven't done the sections 3, 4, 5 stuff yet.
We know how to count.
So do not do 71, do not do 75, okay?
Second R doesn't know you're gonna get questions on it tomorrow.
Then I'll just tell them, oh, I should have told you not to do them. Then they're gonna be mad. Square root of 3, tangent of x.
Mr. Anderson,
Uh-huh,
please, or sir?
uh-huh.
Thank you.
Equals 2 sine of x. The square, did you say? Well, every day.
I guess it.
I'll just sanitize my hands while I wait.
I'm probably going to say that when we get back soon, but.
What don't you like in this problem?
The square root of 3.
Okay,
Oh, the tangent.
people have done this all day. They freaked out about the square root of 3.
We
I'm
could
telling you, the square root of 3 is like the least of your problems.
the tangent and sine.
Tangent.
I don't like tangent and sine. Okay? I didn't like secant and tangent. And you see what that turned into? Okay? In the problem at the beginning, we had sine and cosine. I didn't like sine and cosine. That one turned out a lot easier. I don't like 2 different functions. 2 different functions is bad news. There's really no way to get home with 2 different functions unless it ends up being
Identify.
an identity. Okay? So let's see what we can do here. Talk to me.
Turn it into sine and cosine.
Okay, so square root of 3, sine of x
Over cosine of x.
over cosine of x equals 2 sine of x. Sounds good. What's the next thing you don't like?
Square root of 3.
Fraction, sine and cosine.
True. What else?
The fraction.
There's fraction. Okay, get rid of it.
Multiply by cosine.
Multiply by cosine.
I still don't like it.
Square root of 3, sine of x equals 2 sine of x times cosine of x. Now what don't you like?
The
Still a sine and a cosine. We haven't accomplished anything there yet, but is there anything that you see that might be helpful? Or anything else that you want to get? Squares? Anything good?
Divide by 2.